Okay, so let me get to right there. We're going to go ahead and start 13.5, which is special factoring. I've always loved this section. Okay, so I kind of listed a few things that we've done thus far. And I did actually a lot of writing on this just so a lot of the time wasn't spent writing. So we know how to factor out a GCF. We know how to factor by grouping. We know how to do the AC method. And what we're going to learn now is the difference of squares. In this section is where I thought maybe they would do the sum of cubes and the difference of cubes. And now I don't know if I'm like getting my classes mixed up if y'all only do the difference of squares. So there's a possibility that I misspoke in the end of the last video. Okay, so this is the way I am going to define what we're doing here. Okay, if you have, let me have this. If you have the difference of perfect squares, very important. It's got to be a difference problem and they have to be perfect squares. Okay, you take the product of their square roots, sum, and difference. So product means that we're multiplying, right? So if you look right here, I kind of call this a template. That's definitely not a technical word. I don't really even think they really explain this, but in my mind, I think it's worth noting. Our template, right, factors are sets of parentheses. Our template is going to be 2 sets of parentheses. Take note, the left-hand side of the or and the right-hand side of the or are the exact same thing. This is my attempt to show you that one of the factors needs to have an addition operation. The other factor has to be opposite, which would be like a subtraction operation, a negative operation. And it does not matter the order. The order does not matter at all. Okay. But let's just look at the left-hand side. Do you see how I said that we're going to take the product? Because those two factors are touching, right? Those two parentheses right here in the middle are touching. That means I'm doing multiplication. So that's me taking a product of their square roots, sum, and difference. So because it says sum and difference, it means I'm going to have 1 plus, 1 minus, right? Even looking here, I've got a minus, I've got a plus. I'm going to take their square root, and then I'm going to have a sum and a difference of their square roots, and then I'm going to multiply them together. Okay. Honestly, all you really need to know as far as like the definition is concerned and what you need to remember is just this template, and that it does not matter in which order you write positive or negative. It doesn't matter which one's first or last. So let me go ahead and show you my formula for actually solving these problems. This section, we have 8 examples. So I definitely see this being broken up into multiple videos, okay? So let me move this real quick. Okay, thanks. Right here in the purple, I have a squared and then minus b squared. I have a squared and a negative b squared. So this is saying I have a squared term, another squared term, and I'm taking the difference of them, right? It might not always just be a variable. Your variable could have a coefficient. I believe I very clearly worked through thoroughly every single example. So hopefully nothing gets too confusing or anything. Okay, so if we have a squared term and then we subtract from it another squared term, what we're going to do is we're actually going to take our a term, we're going to take the square root of it. We're going to, and again, these can be in any order, okay? I'm just going to read it the way it's written though. We're going to subtract from that, taking the square of that b squared term that we have, right? That b term. And then we're going to multiply to that the square of our a. We're going to add to that the square of our b. Whenever we do this, there's going to be, I think, a new exponent rule and then a new rule. It's in It's involving radicals. I don't go too in depth in it because we will do it in intermediate algebra. And so at least this is an introduction to one of those processes. But I will introduce those rules to you in the problems, okay? But whenever we take the square root of both of these, what we're going to be left with is just the square root of that term. I know I just pretty much said the same thing because it's kind of hard to say it any different. But looking here, I have the square root of a squared. I just get a, right? And then here, I'm taking the square root of b squared. I just get b. Now, the reason why this works is because if I do b times b, I get b squared, right? Like if I actually do this, I end up getting b squared. So going back and foiling could definitely be something that you do to check your work, as always, okay? So I feel like just saying this doesn't really make any sense. Let me show you this new exponent rule that we're going to use, and then we'll go ahead and do an example, okay? So the new rule that we're going to do, I have right here written in light blue with an asterisk, and I want to explain on the left-hand side, this is saying that if I'm taking a root of something, my n here, that is going to be the root that I'm in. This specifically being general is saying I'm in the nth root. So it says I'm taking the nth root of a to the m. If you have something written in this way, we have a rule. This is an exponent rule, y'all. We have a rule that states that what we can do is actually write that root as a fractional exponent where your root is your denominator and your exponent is your numerator. Okay, so let me look at this example right here. Say we have the square root of x squared, right? If you don't see anything here, it is implied to be a 2, right? When you take the square root, you just draw, that's called a radicand. You just draw the radicand. You don't have to write the number 2 there, right? So, but we're going to imply that it's 2. So if I take the square root of x squared, putting it in this form right here, my root is my denominator, my exponent is my numerator. Y'all, if you do 2 divided by 2, you get 1, right? So if I take the square root of a squared term, what I'm left with is just what was being squared. Okay, that's like another way of saying it, okay? After a while, you can kind of just draw a line through specific parts once you get the understanding of this, okay? Okay, so that's kind of going to be a rule you'll see me use, and then there's going to be another, it's going to be like a radical rule, like a square root rule, or just a root rule, really, that we'll do later. Okay, so let's just go ahead and apply this. I'll do my work in purple. So here I notice that I have x squared, right? That's a squared term. I also have 25. That's a squared term. And I have the fact that there's a negative symbol right here, right? That's a difference. So what I have here is a difference of squares, right? Okay, so let me go ahead and show you. I'm doing this a little bit differently than I honestly ever taught it before. As far as my work is concerned, because I really, really, really want y'all to understand what's going on here, okay? So what I want to do first is, I know that it's written in this form, right? A squared and then a minus b squared. So I'm going to identify, okay, what is my a? My a in this form is x squared, right? I know that in my formula, like what I'm doing is I'm going to end up taking the square root of that, right? So I see that what I do is take the square root of x squared, right? Well, that rule that I just learned says that I could actually write this as x to the exponent over root, right? M over n. And what I get is exponent over root, which is just x, correct? Okay. Y, oh, sorry, I did not mean to write just a. It's supposed to be my a squared. I apologize. Okay, so that's going to be what I use here and here, right? This is now my a. Now let's do the same thing with 25, okay? My b squared is the value 25. I see in my formula, I'm going to take the square root of b squared, which is 25. The square root of 25, use your calculator, you'll get a whole number 5, which means it is a perfect square, correct? Okay, so this right here, this is now my b. And I noticed that right here, I need an a and I need a b. Multiple, I'm going to use it multiple times, but the only 2 letters I see there is an a and a b, correct? So now I'm going to use this template or this template. I don't remember. I think after a while, I kind of get more in the habit of doing, I don't even remember. I'm like pretending to write it in the air. Just knowing that it doesn't really matter. You don't have to put too much thought into it, except for the fact that they have to be different. Okay, they got to be opposite of each other. So I'm going to do my template. Right? Now what I'm going to do is I'm going to take what I found to be my A. I notice that A goes in the first spot of both parentheses, right? And here, what I solved is that it's X, okay? And then now what I do is, now what I do is I notice that here I have a B and a B. It's going to go here and here. And what I solved for my B is 5, okay? 5 and 5. Y'all, that's it. That's your answer, okay? Believe me when I say to you, x times x is x squared, x times 5 is 5x, negative 5x, those would cancel. Right here, 5 times 5, 25, signs are different, so it's negative. Go ahead, go back and FOIL that, okay? The fact that you get right back at this means that what I just taught you and the process you just learned is correct, okay? So now let's do problem 2. I'm not really wanting to show the other problems, but we'll see how this is. I feel like I'm a little too zoomed in here. Okay, so let's do problem 2. So I'm going to go ahead and identify, right? Let me go and write here. I know that I'm ending with, don't know what I did there. Right, that's what I'm looking for. I just didn't write the whole process, right? Taking the square root of, I didn't write all that. Okay, so my a squared is y squared. I know I'm going to take the square root of a squared. I know that I can write this as exponent over root, which ends up just giving me y, which is now, that's my a. Okay, let's look at, just kidding. Let's look at our b squared term, which is 400. I know I'm going to take the square root of b squared, which is 400. I know that the square root of 400 equals 20 because I entered it into my calculator and I got a whole number. What I get here is my b, right? Now let's go ahead and use that template. Does not matter. Let's look. My a's go here. There's my a. And then my b goes here, right? Because I'm looking at this. And my b is 20. Y'all go back and FOIL it. You'll get to y squared and then a negative 400. Okay. So I wanted to do this one for a reason, okay? Okay, so I have x squared and then I have a negative 2. So literally, let's just keep doing. There's something on my screen. Let's keep doing what we've been doing. My a squared, I zoomed in so much, y'all. My a squared is x squared. I know that I'm going to take the square root of a squared. My a squared is x squared. And I know that this can be written as exponent over root, which just simply gives me an x, which is now my a. Okay, and then I know that my b squared here is 2. I know that I need to take the square root of b squared, which is 2. I learn after putting it into my calculator that what I get is 1.414, and it continues, right? Okay, because this is not a whole number, it's an actual decimal approximation. What this means is that this is not a perfect square, right? And so let's just go in there. This is not a perfect square. The answer to a problem that ends up failing one or more of the requirements that we need to do this method is called prime. So the answer would be this polynomial is prime. Okay? Okay, y'all, just time-wise, and the multiple hours it's taken me to upload some videos at home, I'm going to go ahead and stop this one, and we'll start on problem 4 on the next video. Okay? Thanks. Bye.